You know, there's this massive paradox in cloud computing that nobody really likes to talk about.
Mm.
We spend all this time obsessing over the really cool stuff, the technical architecture, the latency, redundancy, spinning up AI clusters in seconds. But the thing that actually keeps CIOs awake at night, it usually isn't the code.
It's the invoice.
It is absolutely the invoice. It's that stomach drop moment when you realize you left a massive server cluster running all weekend,
Oh, yeah.
or when a project that was supposed to cost $500 somehow ends up costing 5,000. Because, I mean, cloud pricing sounds dry, strictly speaking, but in practice, it is often the scariest part of the whole ecosystem.
It's a very real fear. And honestly, if you look at the AWS documentation, it doesn't help much.
Not at all.
It can feel like reading a menu at a restaurant where the prices change depending on how fast you eat, what time of day it is.
And which table you're sitting at.
Right, exactly. It's confusing.
It's confusing by design, or at least by necessity. So, that is our mission for this deep dive. We're going to take this huge stack of sources on AWS pricing, billing, and governance, and we're going to decode that menu.
Right.
We want to move from just renting servers to actually understanding the financial strategy behind the architecture.
Right. And financial strategy is the key phrase there. Because in the cloud, cost isn't just a bill you pay at the end of the month. It's a metric of efficiency.
How so?
If your bill is high but your revenue is higher, that's scaling. If your bill is high and your utilization is low, that's just waste.
Got it. So to help us navigate this, we've got a roadmap. We're going to look at the three big pillars of the AWS bill. First, the compute menu, so the different ways you can buy processing power.
Mhm.
Second, the hidden killers, specifically data transfer and, storage nuances. And finally, governance, the tools you use to actually control this thing so it doesn't control you.
And whether you're prepping for a certification exam or you're just the person at work trying to figure out why the monthly invoice looks like a phone number, this is for you. It's really all about understanding that trade-off between flexibility, commitment, and cost.
Let's unpack this. Let's start with the meat and potatoes of the cloud. Compute, EC2. If I just log into AWS and spin up a server, what am I actually paying for?
Well, the default option, and the one almost everyone starts with, is on demand.
Okay, on demand, what does that actually imply for my wallet?
It means you're paying by the second or by the hour. Depends on the operating system. There is absolutely no long-term commitment. You turn it on, the meter starts running.
You turn it off, it stops.
You turn it off, the meter stops.
Yeah.
Simple as that.
So it's total flexibility.
Exactly. But you pay a premium for that freedom. Think of on-demand like staying in a hotel and paying the rack rate.
Right.
You have the ability to check out whenever you want, but you are paying the highest possible nightly price for that privilege.
So, architecturally, where does on-demand fit? Because the sources suggest you shouldn't be running your whole infrastructure on this model.
Oh, definitely not. On-demand is designed for unpredictable workloads. Maybe you're testing a new app and you don't know if 10 people or 10,000 people are going to show up.
Okay.
Or maybe it's a short-term project that only lasts a week. You pay the higher price to avoid the risk of being locked into a contract.
Okay, but for most businesses, you have a baseline. You know you need some servers running 24/7. You wouldn't pay the hotel nightly rate if you plan to live there for a year.
No, you'd sign a lease.
You'd sign a lease.
That's a perfect analogy. And in AWS, that lease is called a reserved instance, or an RI.
Let's dig into this because the sources make a really interesting distinction here that trips people up. An RI isn't actually a physical server with your name on it, is it?
Correct, and this is the most common misconception. A reserved instance is what they call a billing construct.
A billing construct.
Yeah, think of it as a discount coupon. You're committing to a contract, either 1 year or 3 years, for a specific instance type. In exchange for that commitment, AWS applies a massive discount to your bill. We're talking up to like 72% or even 76% savings compared to on-demand.
So the server itself is exactly the same, the performance is the same.
Identical. You're just changing the math of how you pay for it.
But contracts can be scary. What if I commit to a specific server type, say a memory-optimized one, and then 6 months later my app changes and I need a compute-optimized server instead? Am I just stuck?
Well, that depends entirely on which flavor of RI you bought. The sources distinguish between standard and convertible RIs.
Okay, what's the difference?
A standard RI gives you the deepest discount. That's where you get that 70+% off. But it is rigid.
Okay.
You can't easily change the instance family. If your needs shift, you're kind of stuck.
And the other one?
A convertible RI is exactly what it sounds like. It allows you to exchange the reservation for another one if you need to move to a different instance family.
I see. So the discount isn't quite as high?
Not quite as high, maybe closer to 54%.
Yeah.
But it buys you a safety net. It's hedging your bets.
Right, right. And I noticed in the notes there's also a cash flow aspect to this. You don't just pay monthly.
Right. This is pure accounting strategy. You have 3 payment options: all upfront, partial upfront, or no upfront.
And the logic is simple, I assume.
Very simple. The more cash you give AWS today, the bigger the discount they give you over the life of the term.
So if a company is flush with cash, paying all up front is basically a guaranteed ROI.
It is. It's better than leaving that money in a low-interest bank account.
Now, RIs are great if you have a steady state workload. But what if I have a workload that isn't critical? Like, I need to crunch some numbers, but I don't care if it happens at 2 p.m. or 2 a.m.
Okay, this is where it gets really interesting. You enter the clearance section of AWS. These are called spot instances.
Spot instances. This always sounds a bit like gambling to me.
In a way, it is. You're bidding on AWS's spare capacity. I mean, AWS has these massive data centers, and they're rarely 100% full.
Why?
So rather than let those servers sit idle and collect dust, they sell that capacity at a massive markdown, up to 90% off the on-demand price.
90%. That is hard to ignore. But what's the catch? Why doesn't everyone just use Spot for everything?
Because AWS is the house, and the house always wins. If a paying on-demand customer shows up and needs that capacity, AWS will terminate your Spot instance.
Do you get a warning? Or is it just, poof, server gone?
You get a 2-minute warning.
2 minutes.
That's it. Your application receives a signal, and it has 120 seconds to finish its task, save its state, and shut down gracefully.
So you could be right in the middle of a huge job and just lose the server.
Exactly. So you would never, ever put your company's website or a primary database on a Spot instance. But for fault-tolerant workloads,
Like what?
batch processing, big data analytics, rendering images, things that can pause and restart without breaking, it's a financial superpower.
It sounds like it requires your developers to be pretty savvy, though.
Yeah.
The app has to be built to handle that kind of interruption.
It does, but honestly, designing for failure is a best practice anyway.
That's a good point.
Spot just incentivizes you to actually do it.
I love that distinction. Now, there's a middle ground mentioned in the sources that seems to be getting more popular than RIs. The savings plan.
Yes, if RIs are the old school lease, savings plans are the modern membership.
Okay.
With an RI, you're often committing to a specific server type. With a savings plan, you're committing to a specific amount of spend.
So instead of saying, I'll rent this specific car for a year, I'm saying, I promise to spend $10 an hour on transportation for a year.
Precisely. You commit to a consistent hourly spend for a 1 or 3 year term. And the beauty is the flexibility. It applies across not just EC2, the servers, but also AWS Fargate and Lambda.
That is huge, because if I refactor my app from servers to serverless functions halfway through the year, the savings plan adapts.
It does. You still get up to 66% savings, but you aren't locked into a specific piece of hardware. It's paying for logic rather than metal.
That seems like the way the wind is blowing.
Yeah.
Now, before we leave the compute menu, we should briefly mention the specialty items. What if I work in finance or healthcare, and I have strict compliance rules that say I can't share hardware with anyone else?
Then you're looking at dedicated hosts or dedicated instances. This guarantees physical hardware isolation.
So I'm not sharing the chip with another customer.
Exactly. It's significantly more expensive, but for compliance-heavy workloads, it's often non-negotiable.
And there is one more, capacity reservation.
Right. This is often confused with reserved instances. A capacity reservation doesn't save you money. It saves you a seat.
A seat.
It guarantees that you have capacity in a specific availability zone when you need it.
Yeah.
Think of it like a reservation at a busy restaurant.
Yeah.
You still pay full price for the meal, but you know you won't have to wait for a table.
Got it. Okay, so that's compute. We've bought our processing power. But a server without data is useless. And this brings us to the section of the bill that usually makes people cry. Data transfer.
Ah, yes. The hidden tax of the cloud.
The sources outline a sort of golden rule for data transfer. Can you break that down for us?
The golden rule is simple. Inbound is free. Outbound costs money.
So AWS is like, come on in, bring all your data, we love you.
Exactly. Moving data from the internet or your on-premise data center into AWS is free across all regions. They want your data. But moving data out of AWS to the internet,
That's where they get you.
that's charged based on the region. And that is where people get surprised.
But it's not just leaving AWS that costs money, right? Moving data around inside AWS can also sting you if you aren't careful.
Oh, yeah.
There was a specific gotcha in the source material about NAT gateways. This feels like a trap.
It is a bit of a trap if you aren't paying attention. A NAT gateway is a security tool. It lets your private servers talk to the internet, usually to get updates, without letting the internet talk back to them.
Sounds necessary?
It is necessary. But if you send data through a NAT gateway, you get hit with a double charge.
A double charge.
You pay an hourly service charge just for having the gateway, plus you pay per gigabyte data processing charges for everything that goes through it.
Ouch! So if I'm moving terabytes of data through that gateway, that bill adds up fast.
It does. And the source notes that there are workarounds. For example, if you're just talking to S3 or DynamoDB, you use a VPC endpoint.
And that does what?
It keeps the traffic internal to AWS's network and bypasses that processing fee.
So it's about knowing the map.
It is. Geography equals money. For instance, data transfer within the same availability zone is free.
Okay.
The minute you cross a zone boundary like moving data from us East 1A to us East 1B, the meter starts ticking.
Okay, let's talk about where that data lives. Storage. We have two main players here, EBS and S3.
Right. EBS, Elastic Block Store, that's the hard drive attached to your server. S3 is the object storage where you dump files, backups, images.
And just like compute, there's a whole menu. For EBS, the source is distinguished between SSD and HDD.
Yeah, it just comes down to speed versus cost. If you need high performance, fast read-write for a database, you go with SSD, specifically the general purpose or provisioned IOPS.
But for other things,
If you're just storing big log files that don't need instant access, you can go with HDD to save some money.
But S3 is where the tiered pricing really gets granular. The experts usually use a temperature analogy for this data, right?
They do. It's all about how hot or frequently accessed your data is.
So walk us through the S3 temperature scale.
At the top, you have S3 standard. This is for your hot data. Frequent access, it's the most expensive storage per gigabyte, but retrieval is free and instant.
Okay, makes sense.
Then you cool down to infrequent access. This is cheaper storage, but they charge you a small fee if you access the data. So it's great for backups you might need, but hopefully don't.
And if I have data I just need to archive for regulatory reasons, like keep these tax records for 7 years.
Then you freeze it. You put it in Glacier. Glacier is extremely cheap storage. We're talking fractions of a penny. But the trade-off is retrieval time.
How long?
Deep Archive, for instance, can take hours to get your data back.
Now, here's where it gets tricky. I don't always know how often I'm going to need a file. Today it's hot, tomorrow it's cold. I don't want to have to manually move files around.
And you don't have to. That's why intelligent tiering is such a game changer. The source highlights this specifically. It monitors your access patterns.
So it does the work for me.
If you haven't touched a file in 30 days, it automatically moves it to a cheaper tier. If you access it again, it moves it back. It automates the savings for you.
It sounds like the platform is getting smarter at saving us money, which is nice. But that brings us to the final and maybe most important section, governance. We've got compute, we've got storage data flying around. How do we keep track of all this? How do we organize the chaos?
The foundational tool for this is cost allocation tags.
This sounds boring, but I have a feeling it's critical.
It is absolutely critical. A tag is just a label, a key value pair, like project, alpha, or department. Marketing, you attach these to your resources.
So when the bill comes, I can say, hey, why is the marketing department spending $5,000 on spot instances?
Exactly. Without tags, your bill is just a giant lump sum
Yeah.
of Amazon EC2. You have no idea who spent what. But here's the crucial step that the source material emphasizes. And this is where people fail.
What's that?
You have to activate them.
Wait, they aren't on by default.
No.
Yeah.
You can tag your servers all day long, but until you go into the billing and cost management console and actually toggle those tags to active, they will not show up in your Cost Explorer.
That is a massive pro tip, so it's a manual step.
It is. It trips up a lot of people.
Okay, so tags help us see what's happening. But what if we want to control what happens? Especially if we're a big company with tons of AWS accounts.
That's where AWS Organizations comes in. It lets you group multiple accounts under one master root account. You can create organizational units or OUS, like a dev OU, a prod OU.
And this gives you a single bill.
Yes, consolidated billing. But more importantly, it gives you control through SCP service control policies.
Unpack that. What is an SCP?
Think of an SCP as the ultimate guardrail. It's a policy written in JSON that restricts what users can do in those accounts. And here's the kicker. It affects even the root user of that account.
Whoa, so I can set a policy that says, No one, not even the administrator of the developer account, is allowed to launch the super expensive, oversized servers.
Exactly. Or no one is allowed to run services outside of the U.S. East region. It stops accidental spending before it ever happens. It's enforcement, not just monitoring.
That is powerful. Now, we've mentioned the billing console a few times. The sources distinguish between the macro lens and the micro lens of billing tools.
Right. The macro lens is your standard billing and cost management console. This is where you set budgets, you get alerts if you spend too much, and you use Cost Explorer to visualize trends. Every user needs this.
And the micro lens.
That is the AWS Billing Conductor. This is a more advanced tool. Imagine you're a large enterprise or a reseller. You might want to show your internal teams a different price than what AWS actually charges you.
Why would you do that?
Well, maybe you want to add a markup to cover your IT team's overhead. Or you want to distribute a shared cost, like a support plan, across different departments. Billing Conductor lets you reshape the billing data and perform custom logic before presenting it.
So it's for showback or chargeback?
Exactly those scenarios.
Yeah.
It lets you customize the bill itself. It separates the bill you pay AWS from the bill you show your internal departments.
Okay, let's zoom out. We've covered a lot. From spot instances to Glacier storage to these JSON policies.
And a lot of information.
So what does this all mean? What is the big takeaway for someone listening to this?
I think the big takeaway is that cost on AWS isn't just a price tag you accept. It's a design constraint. It's about intentionality.
Intentionality, I like that.
It's asking, does this workload need to be on demand or can it handle spot? Does this data need to be hot or can it be cold? If you aren't asking those questions, you're just paying a laziness tax.
That's a great way to put it. Don't just pay the default rate. Use the tags, use the savings plans.
And really, if we connect this to the bigger picture, it changes the role of a cloud engineer. You aren't just a technical architect anymore, you're a financial architect.
Which brings us to a thought I want to leave you with today. We talked about tools like intelligent tiering that automatically move your data to save money, and savings plans that automatically apply discounts across different services.
Right. The automation is getting smarter.
So here's the question. If the platform is getting better at automatically optimizing costs, does the future of cloud engineering rely less on configuring the servers themselves and more on configuring the logic of how we pay for them? Are we moving to a world where the code we write is less about CPU cycles and more about business value per dollar?
That is the ultimate metric, isn't it?
Something to think about next time you check that dashboard. Thanks for diving in with us.
Happy to be here.